Alright, so I'm going to show you how to solve the compound inequality and graph it. And what I plan to do is I'm going to show you the two different cases. We're going to solve it as for this OR problem, and I'm also going to change it to an AND problem so you can compare the differences between the two solution sets. First thing you're going to do is you're going to solve each inequality. So I'm going to add 1 to both sides. And I get 4x is less than 20. Divide both sides by 4. X is less than 5. Remember, this is an OR problem, so I'm going to remind myself this is OR. And then here I'm going to solve it again. Add 5 to both sides. 3x is greater than or equal to 6. Divide both sides by 3. And I get x is greater than or equal to 2. Next thing you want to do is graph the inequality. To graph it, I'm going to draw my number line. And I'm going to put the smaller number first, bigger number second. And the first thing I look at is I'm going to graph each inequality. So this is an OR problem. When it's an OR problem, all you have to do is graph both inequalities on the same line. I'm going to graph the first one. I'm going to graph this one. I'll use red to graph this one. And then I'm going to graph the other one in blue. So I'll graph this one in blue so you can see. And what you're looking for is pretty much what is this going to cover on a number line. So I'm going to do the first one here. All numbers less than 5. So less than is an open dot. So I put an open dot on the 5. And all numbers, when I read this, I don't read it as x is less than 5. I tell myself all numbers, in other words, they want all numbers or shade all numbers less than 5. So numbers less than 5 will be this way. So I'm going to shade all these numbers. And it goes forever in that direction. So I'll just put a solid arrow to indicate it keeps going forever. And then the next one, I'm going to graph. It says graph all numbers greater than or equal to 2. So greater than or equal to means I'm including it. So I'll put a solid dot. And then numbers greater than 2 would be to the right. So I keep shading all numbers to the right. And I keep going and going forever. So I'll put a solid arrow to indicate that it goes forever. And I can see here that my solution set is going to be everything. All numbers are covered. You can see there's not one number that's untouched. So for the final answer, it would be like that. Now I just want you to compare this answer like if it was compared to this one. Let's say that if it was, instead of an OR problem, it was an AND problem. I want you to see the difference. So I still do the same thing. I draw a sketch. Small number first, bigger number second. And what you're going to do now is you're going to look for where these two lines intersect. And is looking for the intersection. In other words, where do they overlap? And if I look at this sketch right here, this section here, like if you imagine it to be split up into 3 sections. Right? I have section 1, this is the middle section, and this is the third section on the other end. Right? I just split it up into 3 parts. So if I look at the left side here, section number 1, it's only shaded in blue. Section 2 is shaded in blue and red. Section 3 is only shaded in red. And is asking you to figure out where is it shaded in both colors. And I can clearly see that it's shaded in blue and red in between these two numbers. So if I were to graph x is less than 5 and x is greater than or equal to 2, my final answer would be this solid dot. And it would be all the way up to the 5. And notice there was an open dot on 5. So I will not fill this one in. And I will shade in the middle. So this is the solution set I would put into Alex. One thing I want to point out for this solution up here for OR, a common mistake people do is when they go and put it into Alex, some people do this. They're like, okay, I'm gonna shade. People end up doing this. They'll shade here, here, all this, and then they put an open dot here, which is incorrect. Don't forget that if you look at the number 2, the red, right? That's this number. The graph is on red. It's gonna pass through that open dot. So this will be incorrect. The actual answer for that one, when you put it into Alex, is you should have pretty much everything is shaded. Right? There's nothing untouched. The 2 goes through all the numbers on this side, and 5 is going to be going through all this side. So nothing is open dot. So if you put it in this way, if you put an open dot here, it would be incorrect. So this is the correct way to do it if you put it into Alex. Make sure there's nothing untouched. And again, for and, only look for where do they overlap. Let's look at one more problem and see if it helps. So we're going to look at another problem now. This is solving the compound inequality. And here's an and problem we're starting with. So same thing, just solve it first. So add 1 to both sides. I get 4u is less than or equal to 16. Divide both sides by 4. And I get u is less than or equal to 4. So that's the first one. And, so this is an and problem. Keep in mind, what is it? And versus or. That makes a difference. Here is only one step. All I gotta do, divide both sides by -3. And I get u. And don't forget, if you divide both sides by a negative number, right? I divided this by -3 and this by -3. You gotta flip the inequality sign. And this, when you simplify it, you get -1. So, my solution, and I'm going to change the color so you can see, I'm going to graph u less than or equal to 4 and u less than or equal to -1. So I just changed the color so you can see when I create the graph which one represents the solution set. So again, I look at the small number, -1, put that first on my sketch. 4 is on the right, the bigger number. And I'm going to sketch them out now. So for and, well, actually, let me sketch it first. All numbers less than 4 or equal to 4. This means we're including the 4, so I put a solid dot. Numbers less than 4 would be this way, so I'll shade all these numbers over here. Put a solid arrow to indicate it keeps going forever. And then for the other one, all numbers less than or equal to -1. So I put a solid dot here because we're including it again. And then I shade to the left. And a solid arrow to indicate it keeps going forever. Now keep in mind, when you are going to put your solution into Alex, if it's an and problem, and wants to know which solutions do they share. So for my final answer in Alex, I would put from -1 to 4, and I look for, again, imagine it split up into, or in other words, you don't have to imagine it, you could just think about what section is shaded with blue and red. And I can see that that would be this section right here. Right, so basically from -1, and we're including it, so I put a solid dot, and we're shading to the left. This is the only section that they both have in common. So this will be my final answer for and. And let's look at this if it was an or problem. So if I were to do the same thing, u less than or equal to 4, and then I'm going to make it into an or, so you can see the difference and compare those two answers, or the two solution sets. So again, draw my sketch. Put the two numbers, -1, small number first, bigger number second. And now I'm going to do the same sketch. So numbers less than or equal to 4, I mean a solid dot. And then I will shade to the left. And it goes forever, so I'll put that like that, solid arrow. And then numbers less than or equal to -1. So again, a solid dot, shade to the left, and it goes forever, so I'll put a solid arrow to indicate it keeps going forever. Now for an or problem, what you would do here is all you're looking for is what's shaded. And I can see that our solution is gonna be from +4, all the way to the left forever. So all numbers less than 4 or equal to 4. So my final answer would be that. So if anything is shaded in the graph, it's going to be in your final solution set. So as a reminder, for and, where do they intersect? Where do they overlap? That is the only solution set you would put in your final answer. Or is, as long as it's shaded, you're going to put that in your final answer. So I can see that you're going to shade everything except anything to the right of 4 is not included, and you just got to put a solid dot on 4. So again, we didn't shade this side with a blue or red, therefore I don't put it in my final answer. Alright, and this is going to be our final problem. So solve it first. Subtract 3 to both sides. We get 3x is bigger than 18. Divide both sides by 3. And I get x is bigger than 6. This is an AND problem. So remind yourself what it is. It's an AND. Here I saw add 5 to both sides. Bring down 2x less than or equal to 6. Last step, divide both sides by 2. And I get x is less than or equal to 3. So I'm going to graph this one in red. And I'll graph the other one in blue. So we can see the solutions for each problem. So next thing you do, draw your sketch. And I get small number first, bigger number second. So for the first one, numbers, you want to shade all numbers bigger than 6. So that means I'm going to put a open dot because I'm not including the 6. I want numbers bigger than, not including it. So that means bigger than will be to the right. So I shade to the right. Put a solid arrow to indicate it keeps going forever. And then for the other one, shade all numbers less than 3 or equal to 3. So numbers less than 3 or equal to 3 means I'm going to include the 3 because it can equal it. So I put a solid dot and I shade to the left. So for AND, remember AND is asking you where do these intersect? In other words, is there a section? So if you think about it in terms of like 3 sections, I have my 3 sections. Do any of these sections, section 1, section 2, or section 3, have blue and red shaded in there? Section 1 only has blue, 2 is nothing, and 3 is only red. So since none of the sections have blue and red, so when I say blue and red, meaning I shaded red and I also shaded it in blue. So you can see I don't have any section like that. If that's the case and it's an AND problem, the answer you would put is no solution, because there is no number that is bigger than 6 and also less than 3 at the same time. You can't have that number. And then let's look at if this was a OR problem so you can see the difference. So if this is an OR problem, again I'll do this one in red and I'll do the other one in blue. And this is a OR problem. So you just do your sketch, small number first, bigger number second. Numbers bigger than 6, right? We go this way. Numbers less than or equal to 3, solid dot, and shade to the left. Or it's just telling you to graph both solutions on the same graph. So in Alex, if I were to put this answer into Alex, my final answer would just be from here to the left. And then for the other one, be open dot to the right. Right, you can see the only section that was not shaded was between these two. Therefore, my final answer will look exactly the same. All you're doing is combining the two graphs together. And here, combined together, will look just like that in my final answer. And there you have it. That's how you solve a compound inequality and graph it.